Why do gaseous planets have rings and moons, but rocky planets don't? Let's start with two straightforward assertions supported only by observational data. Jupiter, Saturn, Uranus, and Neptune are all gaseous planets in the solar system. Mercury, Venus, Earth, and Mars are terrestrial planets and lack ring systems. The terrestrial planets are nearly entirely devoid of natural satellites, yet all the gaseous planets have entire legions of them. But regardless of size, whether they are solid or gaseous, every planet in our solar system shares a same beginning. Why can't Earth take pride in its gorgeous ring system? And why are there no moons at all in the skies of Venus and Mercury? What universal law forbids or mandates this? The planets differ from one another in many ways. Yet, to the eyes of a keen observer, it cannot escape the fact that there are two huge, instantly recognizable groups, those of rocky planets and gas giants. Each of them is distinctive in size, constituent elements, appearance, and color. Our solar system contains 8 planets in all. Whereas Jupiter, Saturn, Uranus, and Neptune are massive, gaseous or ice planets, Mercury, Venus, Earth, and Mars are small and rocky. There is a natural separation between the inner and outer solar systems because the first 4 are very different from the others in terms of appearance, composition, evolutionary history, and creation. As every planet, inner and outer, was created from the same disk of gas and dust that encircled the Sun, the question of when and why this separation took place must be answered sometime in the history of planet formation. The most plausible explanation is that the inner and outer disks were separated by an empty area in the disk. The main asteroid belt must have contained such a structure, but it is not yet known whether the gap may have developed due to Jupiter's gravitational pull or the Sun's pull. Yet, it is known that the so-called frost line, which separates the solar system's outer region, where water is only found in the form of ice, from its inner region, where water has been volatilized by the Sun's heat, passes across this separating band. Regardless of how things came out, that barrier has permanently defined the distinction between the inner planets, which are denser, smaller, and uniquely equipped with a solid surface than the outer planets. But there are two major characteristics that immediately stand out. The inner planets have almost no naturally occurring satellites, and none of them have rings, whereas all of the outer planets have. Only 3 of the 221 satellites that have been cataloged to far are from the inner solar system, leaving 218 to the outer solar system. Of course, hearing that all outer planets have rings leaves a lasting impression. An old-school astronomy fanatic from the 1970s would leap up from his chair in response to such a claim and exclaim, "What are you talking about? Only Saturn has rings." In fact, up until 1977, school textbooks claimed that only Saturn could rightfully be referred to as the Lord of the Rings in the solar system. The existence of Saturn's rings has been recognized for a while as they are the most extensive ring system. Galileo Galilei initially noticed them in 1610, but it wasn't until Christian Huygens' discoveries in 1655 that they were identified as such. And we've known for a number of years that the majority of them are made of water ice, with the size of the individual particles ranging from micrometers to meters. The first minor revolution, however, occurred on March 10, 1977. When they analyzed their observations, the astronomers found that the star had briefly vanished 5 times before and after the occultation by Uranus. On that particular day, some astronomers were tracking the occultation of a star by Uranus to study the planet's atmosphere from the Kuiper Airborne Observatory, an aircraft equipped for high-altitude infrared observations with a 91 cm diameter telescope. One and only the existence of extremely thin rings may account for this phenomena. After passing close to Uranus in 1986, the Voyager 2 probe captured images of such a ring system. It was Jupiter's turn to be visited just 2 years later, on March 5, 1979, this time by Voyager 1, and once again there was the surprise of seeing a ring system, although a very faint one. Voyager 2's close approach to Neptune on August 25, 1989, revealed the presence of a system of faint, black rings that are identical to those of Uranus, answering the question of whether the fourth and final gas giant, namely Neptune, was also encircled by rings. The ring lords basically increased from 1 to 4 during the course of 12 years, from 1977 to 1989. It has raised a few important questions for the astronomical community. How are these buildings created? They were created along with the outer planets, therefore are they an inevitable byproduct of that process? Or did they develop unintentionally over time owing to various factors? Why do rings only form on the outer planets? Unbelievably, there is still no consensus on the first question's answer as of right now. Nonetheless, it appears that the alleged Roche limit governs everything. You will definitely recall it. The Roche limit describes the closest point to a planet at which a satellite can orbit without being broken up by its tidal forces. In fact, if an object passed this boundary, the gravitational force it felt on the hemisphere facing the planet would be much stronger than it was on the hemisphere farther away. The tidal forces would be so strong that they would finally outweigh the smaller body's natural gravity, causing it to break. The Roche limit is equivalent to approximately 2.42 times the planet's radius if the planet and satellite have the same density. Within this range, a satellite of discrete size will distort and subsequently disintegrate, but extremely small spacecraft that have an internal cohesive force strong enough to endure gravitational strains will be able to continue circling without any issues. Then there is something else. Outside the Roche boundary, in a disk of fragments encircling a forming planet, matter can gather to form satellites, whereas tidal forces inhibit satellite formation closer to the planet. But to give you a sense of the travel distances, below is what the theoretical limit is for each of the gas giants. Jupiter is 175,000 miles away, Saturn equals 147,000 kilometers, Uranus is equal to 62,000 kilometers. Neptune is equal to 59,000 kilometers. Well, based on these findings, it will be quite informative to confirm, if you so choose, that every planet's ring is contained within its planet's Roche limit. And this is a very strong signal indeed, so much so that based on this result astronomers have devised two hypotheses that could explain the creation of the rings. This is the first. As is well known, the gas giants developed from the accumulation of gas and ice found in the disk of materials that encircled the Sun. The planets themselves, in turn, were encircled by their own accretion disks. Particles from these disks gathered to form satellites over the Roche limit. The remaining material was subsequently constrained in relatively narrow rings by the operation of the so-called and very small shepherd moons below the limit, where tidal pressures prevented aggregation. The second theory suggests that things might have turned out differently. After each planet had finished creating its satellites using all of the material in the disk, one or more of them might have unintentionally slipped below the Roche boundary, where it would have been torn apart by tidal forces and given rise to one or more rings. This is what is currently happening to Mars' satellite Phobos. Any moment throughout the history of the planetary system, even quite lately, an accident could have happened. All of this would lead us to believe that a gas giant eventually developing its own ring system is completely typical. The second query, however, is still unanswered. Why did only the outer planets create rings? The absence of rings on the inner planets would also be explained if the theory that rings form as a result of satellite disintegration were accurate. In fact, it appears that the absence of rings and satellites are connected. Watch to see how. The primary point is that, in comparison to terrestrial planets, the gigantic planets evolved in a radically different environment. The formation of Jupiter, Saturn, Uranus, and Neptune as small solar systems was made possible by the greater amount of open space and the reduced gravitational interference from the Sun. Moreover, the outer solar system was much colder and the only form of water there was ice, which allowed the planets to quickly and significantly increase their mass. The terrestrial planets, on the other hand, formed much closer to the Sun, with much less material surrounding them because the solar veto had turned the water into vapor and dispersed it. They also grew slowly, through the accretion of numerous small rocky planetesimals, never becoming massive enough to form their own disk of gas and dust. Thus, no accretion disks, and as a result, Mercury, Venus, Earth, and Mars never had an opportunity to host satellites. The Moon exists on Earth, and Phobos and Deimos exist on Mars, but they are both exceptional occurrences that have nothing to do with the basic process of formative development. You may be aware that occasionally, Earth collides with a planetoid the size of Mars, forming our Moon. The impact also produced a ring of dust and pebbles, but after a few thousand years, or maybe only a few hours, according to a recent theory, it thickened to give birth to our satellite. Similar to this, the Mars satellites are essentially the outcome of the red planet's causative gravitational capture of two asteroids. Nothing compares to the outer massive planets, which are like actual satellite factories. But hold on a second, we just mentioned that Earth was briefly encircled by a ring system. Why, then, did they not endure? The solution can be found in the fact that the ring most likely developed far outside the Roche barrier of the Earth, which is worth around 18,000 kilometers. The orbiting debris would never have been able to assemble if it had instead formed within. It's also interesting to mention that Mars will feel the joy of realizing it is surrounded by a ring system. That will occur in the not-too-distant future when Phobos, which is likewise approaching the red planet owing to tidal friction, surpasses the Roche limit and fragments into a dusting of rings. Although they will be very fleeting, rings may fall slowly to Earth or be dispersed by the solar wind, which is still highly powerful when compared to Mars.